Hello guys, so my name is Yash and I'm an open source contributor at PSE, and today this workshop is about building privacy preserving polls with MACI. So the objective of this workshop is to understand what is MACI, how it works, why do we need MACI, and a quick demo on MACI wrapper, which is a quick way of getting started with MACI. It includes a front end and the smart contracts. So MACI stands for Minimal Anti-Collusion Infrastructure. So it allows a coordinator to create private polls which have a few properties. The properties include the polls, the votes of the polls are only accessible for the user and the coordinator. So only the user and the coordinator can decrypt it. And the votes cannot be edited, deleted, or censored. Also, there is no way to prove to anyone that this address has voted in certain way. Also, it guarantees correct execution, so it cannot produce false output. Now, why do we need private voting? So, voting in general is susceptible to bribery and manipulation. But if the briber doesn't know how the voter is voting, how you are voting, so it doesn't make sense for him to bribe anyone. Also, we have seen in many occurrences that existing public votes influence the new voters. So if you see a lot of votes are going to a particular candidate, you are more influenced to vote on that particular candidate. So private voting eliminates all of these issues. So going through the architecture of MACI, so MACI consists of a lot of EVM compatible smart contracts, a couple of SIRCOM circuits. One of the circuit is for processing the messages, so processing votes and verifying the validity of the votes. The other SIRCOM circuit is for tallying the vote. It validates the calculation of the summing of the votes. And then there are a couple of TypeScript utilities. One of them is the CLI to interact with the smart contracts and the SIRCOM circuits. Another is a smart contract clone written in TypeScript so that the coordinator can create the whole state of the smart contract on his local computer. And the cryptographic primitives that are being used here are MACI keys, which are EDDSA keys. And the encryption used here is ECDH, elliptic curve Diffie-Hellman encryption. And the hashing algorithms are used here, and ballots. So the user flow is as follows. The user first registers on the platform. While registering, he submits his MACI public key, which is again EDDSA key, to the MACI contract, and then he will be able to send the votes on the existing polls or the new polls, the upcoming polls on the MACI contract. So that process include creation of a vote message. That message will be encrypted by a ECDH shared key, which is a pair of a random key and the coordinator public key. And then this message is signed with the MACI private key. Now, after the execution of this poll, the results will be verifiable on chain after the coordinator has processed all the messages and tallied votes. So the MACI votes have a few properties. Every single vote message has a nonce, which can be used to track the order of the messages. And it can be used to change your vote later. So you can submit the vote again with the same nonce as you submitted before, and the previous vote will be replaced by the new vote. Now, every vote can also have weights. So we can have like a election where every user gets, let's say, 100 votes, 100 voting power. And then while voting, you can select 4 different candidates and give them 25 voting power each. So you can have something like that also there. And anyone, irrespective of whether you have signed up or not, you can vote, but only the signed up votes will be counted. And then the finalization process involves the coordinator first merging the sign up tree and the messages tree. Then the MACI state is generated locally using the TypeScript contract that I described before. And then he would process all the messages locally, generate a zk-SNARK proof for this processing, submit this proof on chain with the commitment hashes, and then he would tally all the votes locally and submit the proof again on the smart contract. So anyone who has voted or not voted can verify on the smart contract the validity of the tally of the vote. Now, here are a few links. I will share this slide on the PSE channel on the ETHIndia Telegram server. And so basically, there are like three parts which you can look at of the documentation. One is the MACI GitHub repository. Another is the MACI platform GitHub repository. And third is MACI wrapper, which I'm going to show the demo of. So MACI wrapper, let me show this demo. So basically, I will share this link on the channel, but you need to first clone the repository. 1 second. I don't know if you are able to hear the audio or not. Please raise your hand. Okay. Okay. I'll just play this. Audio connected नहीं है? Okay. It was not connected before. 1 second. Okay, 1 second. 1 second. Headphone settings. Where? Speak. External headphones. Okay. Hilarious. Now that's why I really don't like this headphone setup. Okay. So I will just mute this and do a walkthrough. So basically, you first need to clone the project, and I will add these links on the Telegram channel. Now, after you clone the project, you will need to download the Z keys. But for saving time, I'm just gonna copy paste the Z keys from my computer. But once you run the yarn download Z keys command, you will be able to download the Z keys required for building this project. Now, so I'm just copying that, and then after that, this is a scaffold ETH project which contains two packages. One is the hardhead package, another is the Next.js package. So the hardhead package contains all the contracts, and this is the MACI wrapper contract. Now the Next.js project, sorry, the hardhead project also contains the deployed contracts.json file. As you deploy more contracts, the contract addresses will be updated here. You will also see a deploy config.json file just above the deployed contract.json file. So that file, you will need to add it once you want to generate proofs. So I will show that later in the video. So, and this is the scaffold.config.ts file, which would be present in the Next.js package. Now, in this package, you will be able to change the target network. So currently, it's set to the hardhead network, and that's why it will work on the local chain. Now, so after this, you need to create these environment files, and I will just copy paste one of the environment file from my computer. But basically, these two variables are required: the Pinata JWT and the Pinata gateway. So you will need to create a Pinata account to set up this project, and you will get this config. And the other two variables are not required, but you can add the Alchemy key for the better support. And also the Wallet Connect project ID is not required. If you want to support Wallet Connect, yeah, you can add that. And after adding those environment variable, you can start the hardhead chain using yarn chain command. The command is also written on the GitHub README. And then you can run the yarn deploy command to deploy these contracts. Now after that, you need to run yarn start. So yarn start will start the Next.js server for you. So this is the MACI wrapper project. So it's loading. Okay. So the first step is the registration. So when you will open this for the first time, it will ask for connecting through MetaMask. And after that, it would ask for the signature request. Basically, what's happening is the signature is the seed to create a key, a MACI key, and that would be registered with the MACI contract. So everyone who has registered using this process will be able to vote in the future votes in future polls. So, yeah. Then you can also see the contract addresses.json file here and the coordinator key pair.json file here. The coordinator key pair.json file is created when you are deploying the contracts. So it's used like it has the private key for the coordinator and the public key for the coordinator. We will need those later. Also, the deployer address by default is set in the hardhead config file on line number 74. So this address you will need to add to your MetaMask, or you can change the deployer private key using the environment variable deployer_private_key in the environment file to use the admin panel, which I will show in a second. So you can see on the top we have three tabs: home, debug contracts, and admin. The admin panel will only be accessible to the deployer by default. Now, on the admin panel, you will be able to see a create poll button, and you can create polls from here. So I'm just creating a dummy poll one with a random expiry and 2 candidates. Now, for poll types, there are 3 poll types which you will be able to see. A single candidate select, a multiple candidate select, and a weighted multiple candidate select. So the single candidate select is for like simple elections, where you just want the voters to elect for to select just one candidate, and for multiple candidates select, it will have checkboxes, and it's like you will be able to select multiple candidates, the name suggests. And the weighted multiple candidate select is also like that. So every user by default get 100 votes, 100 voting power, and in weighted multiple candidate select, they will be able to allocate this 100 voting power to different candidates. Now for voting types, we have two voting types, quadratic votes and non-quadratic vote. I'm selecting non-quadratic for now. Then candidate names, C1 and C2 for now. And then the poll is created by a signature. So another thing, let me show you this error. This is important. You might see occasionally this error, internal JSON RPC error. This signifies that your MetaMask is having old state, and you might need to clean that up because it's a hard-hat MetaMask problem. So you will need to open your MetaMask, go in settings, and then go to advanced, and then clean the activity tab data. And then you will be able to create transactions. Okay, so the poll is not started yet. It would be started in a few seconds once you create it. So let me just skip forward. And I'm also opening one incognito tab for another user. And this is using a burner address, so you don't need to connect multiple wallets. If you're using the MACI wrapper, it would create burner wallets for different windows. And you can add funds using the faucet. So the faucet button is on the top right. Then you need to register. I'm creating another poll because that one was expired. So the same poll, yeah. Poll is created. Now we can see those polls on the home page, and the polls have not started yet. So they have started now, and I'm voting for C2. And after that, I would go to the admin panel, and the poll status is still open. It would expire in a couple of minutes. So you can see on the screen the time was 31, and the poll would expire at 32. So I'm just going to skip forward. Then the coordinator, because the coordinator is currently responsible for creating the polls and uploading the proofs. So he needs to upload the tally file, which will display a chart. So this tally file can be generated using, again, some commands which are present on the GitHub README. So the last seven section contains those commands. So you will need to update the deploy config.json file for generating the tally file. Here you need to go to the specific network you have deployed to. So it contains all the networks. You need to go to localhost because we are currently using hardhat. And then you need to update the coordinator public key and the use quadratic voting flag. So this flag is by default true, but as we were using non-quadratic voting, we need to set it to false. And you can find these keys in the coordinator keypair.json file. And then after setting this config, you need to run these couple of commands. One is to merge the state tree and the message tree. So this creates the Merkle proofs. As it was second poll and the indexes are 0 based, so the poll ID would be 1, and we are merging that. So again, another important error to look forward is hardhat doesn't mine blocks if you're not running transactions actively. But the poll is over, so you need to just create another transaction for it to create another block so that the voting period is over. So we would go to the scaffold ETH project, and we would use the faucet to add funds to the hardhat, to add funds to this wallet. That creates another transaction. So once we have created that transaction, we can go back here and run the same command. So it merged the trees. And then we need to generate the proof. So for generating proof, this command can be used. You need to change the poll ID and the output directory for the proofs. Poll ID is 1. Output directory, I'm just setting it to output for now. And the coordinator key pair, coordinator private key, you can find this again in the coordinator key pair.json file. And then you can set the tally output file to tally.json. Now after that, it would generate the proofs, and you will be able to find the tally file in the harded package. This is the tally file. We will upload that tally file on the admin panel. After uploading that, you can see the results. So basically, this was the demo. And now going on to bounties. So we have like $2,500 worth of bounties. You can scan this QR code to see more. And now to reach us, this is you can scan this to join our Discord server. Also on the ETHIndia Telegram, you will find PSC channel, and you can ask questions there. And here are some useful links. I will again share the slides on the Telegram channel, so you can find all the information there. Thank you.